Okay, hello everyone, and welcome this morning or afternoon, depending which country you're calling from, to the SMR overview. We're going to cover the perspectives both from North America with Mark from Canada, and we also have Mike from the UK from Rolls Royce as well. So thank you for joining us. We'll just do a brief overview of what NAYGN and NIYGN is before introducing our two panelists here. The panelists will then go through a presentation. We'll switch it from first a Canadian perspective. We'll then do the UK perspective, and we'll leave lots of time at the end for your questions. So during any time during the presentation, you can type your questions into the chat feature, and we'll address them on a first come, first served basis at the end. You'll also have the opportunity to raise your hand or ask questions live at the end. And this is being recorded, so we will share it with our YouTube page after. So I'll start with Sarah to give an overview of NIYGN, and we'll get started.
Hi everyone, so I'm Sarah De Lima. I'm the Vice Chair for the UK NIYGN. So that's the Nuclear Institute's Young Generation Network. So the Young Generation Network is under the Nuclear Institute, which is the UK's professional body and learned society for the nuclear sector. The UK YGN has existed for over 20 years and has approximately 1,250 members, and we support collaboration and professional development in the UK and around the world, which is why we're really proud to be supporting this webinar alongside NAYGN. So I'll let Matt introduce a little bit more about NAYGN now.
Yeah, so there are 50 young generation networks around the world. NAYGN is the North American version. So it's North American Young Generation in Nuclear. You can join for free, be on our mailing list, and get updates about webinars, development opportunities, all types of different things. We do have 120 different chapters all across the continent. We were established in 1999 as a nonprofit organization. And we have somewhere just over 10,000 of our members, and membership is free. Another thing I did want to mention is we will be hosting our Continental Conference June 21st to 23rd in Minneapolis. And so yeah, lots of great opportunities there. I've just thrown that in the chat here. But yes, I'm thrilled to be working with the UK version of the Young Generation Network. And yeah, I think we have a great presentation here. So I will introduce Mark. So Mark Fergala started his career at Bruce Power as a system engineer for the CANDO fueling machines before moving to Honeywell's Smart Grid Solutions. In 2016, he joined Ontario Power Generation as a section manager in the projects organization to manage a portfolio of projects as part of the Darlington refurbishment program. And in 2020, Mark joined OPG's Darlington New Nuclear Project as a senior manager in projects. So Mark, I will turn it over for you, and you'll give us a nice overview of what Canada is doing for SMRs.
Okay, thank you very much, Matt. Good morning and afternoon, everyone. So as mentioned, my name is Mark Fergala, Senior Manager on Darlington New Nuclear Project. Pull up the presentation here. So today I'll be speaking to everyone around small modular reactors, what the plans are within Ontario and abroad, and some different avenues that OPG is looking at tackling the space. So first, what I'd like to do is start off with a land acknowledgement. So OPG's facilities across Ontario are located on traditional and treaty territories of Indigenous peoples. To acknowledge these traditional treaty territories is to recognize the history predating the establishment of the earliest European colonies. It's also to acknowledge the significance for the Indigenous people who live and continue to live upon its lands, and to acknowledge that these people practice, or the people's practices and spiritualities are tied to the land, water, and continue to develop in relation to the territory and its other inhabitants today. It is important to take time to acknowledge these treaties and territories, as a reminder of the privileges and benefits that we've enjoyed as citizens of Ontario and are rooted in the long-standing treaties and historical relationships between Indigenous and non-Indigenous people. As a company, we remain committed to fostering positive and mutually beneficial relationships through the Indigenous people and communities across Ontario, which we'll go into later in the presentation. So who are we? So Ontario Power Generation is proud to be the largest and most diverse clean energy producer in North America. We invest millions into the local economies and and employ thousands of people to maintain a modern and sophisticated energy group. So overall, if you look at where Ontario is, we've got a nuclear energy fleet of 2 stations that are owned and operated by OPG, as well as 2 stations that are owned and leased to Bruce Power to run, as well as several thermal, solar, and hydroelectric stations. And then to complement that, we have a collection of US hydroelectric, as well as a subsidiary of hydropower, overall generating just under 19,000 megawatts of capacity for Ontario, and with about 100 years plus of energy generation experience. So one thing that we wanted to talk about today around small modular reactors is that we have a large challenge and opportunity within the energy market today. In 2020, we released our first ever climate action plan to become a zero carbon company by 2040, with the ultimate goal that Ontario becomes a zero carbon economy by 2050. So this is a significant opportunity and provides us with a lot of different avenues that we can go down, some of which are SMRs, which we'll speak to today, as well as other avenues such as hydrogen, the Darlington refurbishment project, continued investment in our hydroelectric generation, as well as other adaptations and electrifications of other technologies and industries throughout Ontario. So this is a bit of a background in terms of the scenario that Ontario is in. Our independent electrical systems operator, the IESO, released a pathways report for decarbonization. So if you look at the green line, the 2022 plan is the kind of projected target based off of what our current market looks like. But the pathway scenario is really what will happen if Ontario decarbonizes entirely by 2050. So as you can see, that line changes dramatically, almost doubling the amount of generation required to sustain the economy for the electrification activities. And this is through ways of decarbonizing transit, looking at different industries, and moving some of the kind of carbon emitting fuel or energy sources into renewable or carbon-free generation. So there's a significant opportunity here within Ontario for OPG to capture, as well as a province to kind of decarbonize our entire industry. So what this would look practically is we'd be looking at potentially tripling our nuclear fleet from what it is today, as well as significant investments in other energy sources, partnering with Indigenous communities for advancement of technologies and different power plants, as well as developing innovative solutions for specifically purpose-built for that application. So again, a little bit more breakdown of what we would need to develop to capture that pathways projections, but again, significant opportunity for our industry, and really exemplifying how we're leading the decarbonization and how there is a realistic path to get there. So why OPG? So in order to help with this plan, we launched our refurbishment project in 2016. And with that was the execution. There was a lot of planning that went in, 10 years of planning to go into that. But really what this is an opportunity for us to demonstrate that we have what it takes to run complex mega projects on time and on budget. Currently, we are wrapping up Unit 3 on time and on budget. Unit 2 is completed and returned to service safely during the pandemic. And then we are in Unit 1 and scheduled to begin Unit 4 at the end of 2023. So what this will do is replace all of the wear components from our existing CANDU fleets at our Darlington facility, and replace them with new components to extend the life for 30 years. So what this practically does for the province required an initial capital investment, but has resulted in around 14,000 plus jobs, over almost $90 billion of GDP boost to Ontario, as well as providing continued low cost and safe and reliable energy for Ontario. Now, doing this, again, demonstrates that we can do these mega projects on time, which leads us into the small modular reactors. So for those that might not be aware, small modular reactors are kind of the next evolution of nuclear energy. They're really designed using the same technology, but safer, more reliable, and using modularization wherever possible. So based on the same fission science, looking in different applications, which we'll go into on-grid, off-grid, and advanced. And then some of these technologies, they're just further evolutions of already existing and tested technologies such as the BWRs, which is the project that we're working on for the Darlington New Nuclear Project. So as mentioned, right now we're looking at three different avenues. So the on-grid SMR, this is anywhere from a power output of 150 to 300. So providing that baseload generation, looking to displace as much coal or gas fire generation as possible, and making kind of near-term deployment goals, which is our BWRX 300 partnership with GE Hitachi. We're looking for a commercial on-site as early as 2030. For the next phase or next area, would be looking at advanced reactors. So these are kind of smaller. They're about 10 to 150, looking at heavy industrial applications and looking to be deployed in the mid-2030s. So this would be ARC, Moltex, and X-Energy. And then the final one is off-grid SMR. So these are much smaller, sometimes called micro modular reactors, but anywhere between 1 to 10 megawatts output, looking at applications for remote or industrial or off-grid communities, providing them with clean energy and removing that dependence on fossil fuels or other energy sources. And some examples of that are the Global First Power Micro Modular Reactor, which is a subsidiary of OPG, and the Westinghouse eVinci. So what this means for Canada and for OPG is really we are looking at a fleet approach. So this would mean deployments in other provinces that have not had nuclear power up until this point. So there's been a memo of understanding signed between Ontario, Saskatchewan, New Brunswick, and Alberta to cooperate on the advancement of SMRs. So looking at grid scale SMRs in Ontario, New Brunswick, and Alberta, and then potentially looking at small modular or micro modular reactors, or kind of the more advanced ones for some of the other provinces such as and territories such as Alberta, Nunavut, Northwest Territories. And then looking further than that, leveraging that fleet approach, there are other countries throughout the world that are looking at the same approach and same technologies. Some of the most immediate are with Synthos in Poland, and Tennessee Valley Authority in Tennessee has signed a collaboration agreement on the BWRX to develop a standard plant design that can be deployed kind of throughout the world, and then with some minor engineering to make it specific for a specific location. Some other countries that have interest are Cernavodă in Romania, or sorry, Bucharest and Cernavodă in Romania, the Czech Republic, and Estonia and Australia. So we'll first go into the advanced reactor. So what actually happened was the X-Energy XE100 was part of the technology selection and down select, and it was a promising technology. And as a result, OPG has actually invested 30 million US into the company to continue to develop the technology and help get it to the point where it can be deployed in certain locations and applications. And this is on top of the 10 million US already invested as part of our technology selection process 2 years ago. But this is really a advanced reactor, kind of technically a Gen 4. It works off of a TRISO fuel pellet, which is that sphere just in front of the trucking container, and really builds on decades of high temperature gas reactor technology and research, creating about 80 megawatts of electricity and about 200 megawatts of thermal power. This would be ideal for high quality steam or other industrial applications such as the oil sands or in mining. Some of the off-grid SMRs, so this is an example of the Global First Power Micro Modular Reactor. So we'd be looking to provide a demonstration reactor in Chalk River Laboratories with a Ultra Safe Nuclear Corporation USNC designed micro modular reactor. So right now they've applied for the license to prepare site and the environmental assessment is underway, but this would generate about 100 or 15 megawatts of heat energy, about 5 megawatts of electricity, and the lifespan is intended to be about 20 years, after which the reactor would be decommissioned and the site restored. So very kind of hands-off, simple technology that can be applied for remote communities or heavy mining, for instance, that would be able to provide and remove some of the carbon emitting sources of energy for those industries. So the Darlington New Nuclear Project is the project that I'm on. We're looking at deploying a on-grid BWRX 300 reactor as early as 2030. So there's been significant milestones and achievements from the team. We've just actually recently finished our submission of license to construct. There's several packages that go to the Canadian Nuclear Safety Council, so the CNSC. But really, we're full steam ahead on providing Ontario with clean energy from a small modular reactor by the end of this decade, which is pretty significant based off of some of the history on some of these mega projects. So we've signed a partnership agreement. So rather than continuing in a standard commercial agreement, we've moved into an IPD, so an integrated project delivery model, which provides us with really a best athlete approach, ensuring that the right people are in the right places to make the right decisions as we progress forward. And we've signed that with GE Hitachi as the technology developer, SNC-Lavalin as the architect engineer, providing designs and site-specific details for the GE Hitachi design, and then NAYGN is the constructor for the project. So an overview of the technology. So I think it's the 10th evolution of the BWR technology that GE has deployed throughout North America and the world. So it's really a miniaturization with some passive safety features that will allow for a 60-year operating life, generating slightly over 300 megawatts, but is a boiling water reactor, very well-known, lots of operating experience throughout the world. And leveraging with our partnership with Tennessee Valley Authority, incorporating all of those lessons learned into the design process as we progress and get to the actual construction of the BWR 300 at Darlington. So for looking ahead in this year where we are right now, so we are beginning or continuing our site preparations work. That means preparing, grading, degrubbing the area, getting it ready for and some of the construction infrastructure as well as the actual construction of the plant. We have signed our IPD, setting up the organization, making sure that we are advancing, putting again the right players in place for the different roles, and beginning our public engagement on our license to construct application, and continuing to collaborate with GE on the SMR design to get it to begin construction once the license to construct has been issued from the CNSC. So the major milestones that we'd be looking at are, we've achieved, as I mentioned, some big ones with the license to construct being the first of its kind in Canada under the current process and regulatory framework. So that has been completed and all packages have been submitted. We're looking for a public hearing with the CNSC on our license to construct by the middle of 2024. And then the LTC itself, license to construct, to be issued by the end of 2024, which would allow us to begin construction of the actual power plant, and then license to operate issued by the end of 2028, and then beginning loading fuel, commissioning, and beginning commercial operations in 2029. So as mentioned previously, the Indigenous engagement and Indigenous communities are key in how we're doing this. So from the get-go, we've been involving the communities, leveraging the knowledge from those communities and bringing information about the design, any of the environmental impacts, and walking them through the assessment, making sure that the communities are aware of what the implications of the plant are, and ensuring that we are following our reconciliation plan. So this is a big initiative for the company, and I think a strength that we have, that we have a reconciliation action plan developed. The consultations and engagement of the communities on the SMRs is a big part of that. And whenever we are getting through major kind of design milestones, as well as ensuring that we have continuous engagement with the Indigenous communities as we go through the process to make sure that their voice is heard. We're incorporating their knowledge and their stewardship of the lands into what we do, and that it is a continual input and consultation as we get through this process. And that brings us to the end of the OPG Small Modular Reactor presentation. So I really appreciate everyone's interest. I think this is going to be a very, very exciting industry. It's kind of the first time in my career we've had a bit of a nuclear renaissance where a lot of countries and companies around the world are looking at it. So it's exciting to be number one, but definitely looking forward to the future deployments of some of these technologies as we prove that we can do it once and do it repeatedly in other places.
Thank you for that, Mark. I see the questions are streaming in, so you can continue to put your questions in, and we'll get to them all after this next presentation. So I'll turn it over now to Sarah for the UK perspective.
Great, and thanks, Mark, for your presentation. Really interesting to hear from the Canadian perspective, the technological, but also the people and community aspect. So from the UK side, we have Mike Crawford. Crawford, is the Business Development Manager for the Rolls Royce SMR, bringing experience of 12 years in the nuclear industry to help meet the twin challenges of decarbonisation and energy security. Specialising in technology introduction programmes, Mike has worked across the breadth of the nuclear industry, including the UK's Dreadnought submarine programme, decommissioning, development of a microreactor, looking to decarbonise the deployed power sector solutions to the upcoming challenges in the European medical radioisotope supply chain, and the genesis of a UK programme to develop space-based nuclear power and propulsion technologies supporting NASA's Artemis programme. Mike is now working primarily with industrial energy users and policymakers to develop new ways to apply nuclear solutions to the energy ecosystems of tomorrow, driving down the system costs of the energy transition. Over to you, Mike.
Sarah, and yeah, I'll take the baton to share what's happening with Rolls Royce SMR and the UK perspective. So hopefully you can all see the full screen. So Rolls Royce SMR is a spin-off from the Rolls Royce PLC group, which has been around for over 100 years, a household name now. You might be familiar with what Rolls Royce PLC has activity within. So civil aerospace is definitely the main sector of activity historically, lots of experience in that engine design and turbine systems. They also do things in the marine sector and deployed power with diesel generators and reciprocal diesel engines. A third leg of the business has always been defence and powering defence. So part of that, as well as aerospace and the planes, is the work that we've done in the UK submarine enterprise. So for the last 60 years, Rolls-Royce has designed, tested, manufactured, and supported through life, and even now decommissioned or started to decommission those submarine reactors for the UK submarine fleet. So a huge amount of experience and heritage in nuclear and across the whole life cycle. Recently, that spun off into the Rolls-Royce SMR program, which is now its own separate business, as well as an innovation and future programs division looking at novel nuclear applications, whether that's microreactors and space nuclear power and all that exciting stuff. So as Rolls-Royce SMR, we have pretty much a laser focus on deploying the SMR solution. So we ignore all the other possible nuclear technology space and narrow down into just the SMRs. This is our timeline for deployment, and as you can see, we've completed the first stage of our program, which was to really understand and create that concept design. So that basis of design is now complete, and we're in stage 2, which is the licensing and justification step. So we're going through the regulatory assessment in the UK, which is the generic design assessment. We should complete that in around 2026. We have just completed step 1 of 3, so a real good milestone, a lot of hard work from the team. But there's a real long road still to go there. A lot of testing, a lot of analysis, and a lot of documents to write. In parallel to that, we're also securing orders and creating those first projects to really get sites and to really get projects moving. So that's the challenge that we now face. Moving then into stage 3 is all around the commercialization and delivering. So it's about setting up those supply chains, the manufacturing capability, whether that's external or internal to what we're doing within Rolls Royce SMR, and then actually operations on site, so clearing land, building, testing and commissioning, and finally getting that all-important power onto the grid. Where we sit in the technology space is fairly neutral. So we're a pressurized water reactor, which is about as standard as it gets in nuclear these days. It's an ever widening technology space that Mark sort of touched on in the last presentation. We are a little on the large side for an SMR. So we're 470 megawatts of net electrical output, which is big, but that was a purposeful decision in order to minimize the levelized cost of power from our plant. And each of our SMR assets is going to be designed to last for at least 60 years, which appears to be the standard these days for any new nuclear asset. Different for some of the real small scale stuff, again, as Mark touched on, but for large scale and SMRs, 60 years is the minimum that people are targeting, thanks to advances in materials science and things like that from the last sort of 30 years. That's it in terms of there's no real new novelty there in the technology space for us. Where we have innovated as Rolls Royce SMR is in how we're going to manufacture and deliver these things. So that's the pain points of the last few decades of nuclear delivery has been in the manufacture and the construction on site. That's what we're looking to change. So you can see from this graphic here that our plant is truly modular, so built up from a number of standardized modules. So these sort of blue frames you can see in the bottom left. That standard frame structure is common across the entire power plant, so not just the reactor itself, but the entire power plant, the turbine island, the balance of plant systems, even into the cooling water island. And that for us is critical to protect against those cost and schedule overruns. We need to capture that value of factory production, factory testing, and capture that across the entire power plant to ensure that we can control and deliver this thing on time and really commoditize this as a product, or commoditize nuclear as a product. And that's paving the way then for SMRs and modular micro modular reactors to really be off the shelf products, or as close as you're ever going to get in the nuclear industry. As well as making all these modules in factories, we plan to construct the entire site within a site factory that you can see here. This structure will have a canopy across it. It's got a number of very clever swarm mechanic cranes in there, and enables you to build 24/7, whatever the weather, whatever the conditions. You are protected, you are safe. That's great for the internal environment, to protect the quality of that build and to protect the schedule and costs. But it's also great for the external environment and protects the surrounding community from what's going on inside, whether that's noise pollution, light pollution, whatever. So yeah, another critical innovation in how we're going to deliver this. Here's a quick walkthrough of what that looks like. So the modules are constructed across 3 separate families. So we have the pressure vessels, the real sort of nuclear reactor specific bits in the reactor pressure vessel, the pressurizers, the steam generators. Then we have the systems modules, which is those mechanical, electrical, and plumbing modules. Lots of pipe work, valves, things like that. And then even the civil aspects of the plant are modularized, so concrete, steel, these structural elements, whether that's the real simple like walkways and access pathways, or the complicated civil loading structures of the plant. We will also have a asymmetric bearing at the bottom of each of these plants. Now, we've added that into the design to make sure that when we do fulfill the promise of fleet deployment, not just one of a kind, we don't have to redesign for each specific site. So that aseismic bearing is going to be tuned for each specific site. And assuming that site is within the range that we've had approved from the regulator, then we've got good confidence that we can copy paste everything else is exactly the same, and we don't need to do any site to site redesign of the plant itself, the primary plant. So very useful to have. And the only other thing I'll mention here is obviously we've touched on it in the last presentation, but SMRs are small. They're small for the S in small modular reactor, but they're small in terms of the generation footprint compared to any other kind of energy generation technology. And it's a factor that's becoming increasingly more important as we go forward and realize the scale of energy that we need over the coming decades. So I will leave it there in terms of what the Rolls Royce SMR plant. As a bit of context in terms of the UK, so we saw a similar chart to this for Ontario. This is the UK's energy consumption in 2021, and I'm sure you guys have seen charts like this to death, but the point being, electrical power is around 20%, it's 18 of the total energy mix. And if we're going to decarbonize that, great, that's a start. But it's it's only 1/5 of the total problem that we face. And so having a solution to decarbonize the other 2 is critically important. And you can see here that represents around 150 gigawatts. That is a not insignificant amount of power. Rolls Royce as a group is investing in a lot of technologies across the energy space. So they have an ambition to be part of the solution for the energy transition rather than the problem. And so it's not just about SMRs, it's about that whole technology space, and critically the gaps in between those technologies. Creating a load of clever technologies in isolation does not solve the problems we have, but creating technology ecosystems that can work together to solve those problems is going to be really important, whether that's in hydrogen and electrolyzers and fuel cells, things like micro reactors. So part of the novel nuclear sector in Rolls Royce, they are developing a sort of deployable micro reactor, or other micro grid controls and including renewables like deployable solar and things like that. Rolls Royce ultimately wants to decarbonize flying, because that's a key emissions profile for the company. And in order to keep those planes in the sky into the long term, we need to find a sustainable way of fueling them. And that goes across society as a whole. So across, whether it is aerospace or whether it's steel production, whether it's, just us living our lives and moving around cities and towns, whatever the challenge is, there are solutions. The technological solutions exist. The trouble is, it's the energy to power them. That's what we don't have. And so at Rolls Royce SMR, we're very clear that we can have a role to play in a huge range of use cases to really power the heart of this energy transition. And that goes for the wide range of nuclear technologies. Specifically, we look across a number of use cases, and that includes not only the provision of electrical power, which you can see here in blue, but also absolutely the provision of thermal power. And I think there was a question already in the chat. Definitely, decarbonisation of thermal power is a big challenge. It's definitely an area where nuclear technologies can play a big role. And it's, I would say, an area that has been undercapitalised to date. And there's definitely a lot more work done there to realise these solutions. Tying some of that together is hydrogen, which, as far as I'm concerned, is going to be huge. And there are questions around certain use cases, absolutely. But ultimately, we will need lots of green, clean hydrogen if we're going to decarbonise the full 100% of our energy use. And a lot of that will be used then for follow-on applications, such as feedstocks or such as future fuels. So if we can produce cost-effective hydrogen, including the likes of high-temperature steam electrolysis, then we really have a chance to start making a difference. The nuclear landscape in the UK, is depending on which lens you look at it. You can sort of come out with a happier view or not. This is the existing nuclear generation, and so this chart was from March 22, and there's actually some errors in it. It's from the BBC, but March 22 feels recent enough-ish, especially in the nuclear industry. It might as well be, yesterday's paper. But actually, since then, we no longer have those three. So already there's 5 reactors left in the UK that are actively contributing to our grid, and by 2028 there'll only be 1, Sizewell B, and that puts us 1 reactor better than Germany in 5 years' time. So it's quite a stark picture. There's good stuff going on in technology development space, which we'll come to, but the critical reality of how many green electrons are going onto that grid, it's going to get worse and worse, unfortunately. And at this point, there's not a whole lot we can do about it. Hinkley Point C will potentially come online 2028, so might just come online there to add a second. And Sizewell C is in negotiations with the government at the minute. So that's the state of affairs in the UK. And what do we need to change that? Well, we need 6 pillars, six sort of enabling functions to be able to deploy an SMR. We often talk on the left-hand side of this, we talk about the technology, we talk about the regulation and policy. That's very important, but actually equally as important, we need operator capability, we need sites, we need off-takers and off-take agreements, and we need the money. Those don't often get the airtime that they need. As a technology vendor, we certainly sit on that left-hand side. So that's where we can comfortably talk. That's what we're on the hook to provide. And indeed, we're moving ahead with our technology design development and the regulatory processes we've already discussed. But there's definitely a lot of work to be done as we go towards the right-hand side of this. The UK government recognises that, and so an organisation called Great British Nuclear is being created to help sort of close those gaps and help move up these pillars towards getting real projects off the ground and getting new nuclear deployed. It remains to be seen quite what shape Great British Nuclear will take and exactly what will be in its remit to do, and how much funding critically will be behind it to do so. But nonetheless, the intent is to move us up those pillars and realise more nuclear deployment in the UK, up to the target of 24 gigawatts by 2050. We saw a little bit about the worldwide context on Mark's presentation, and here's a bit more. There's a lot of activity, there's a lot of commitments, and not everywhere is pro-nuclear, as we've seen Germany shutting down the last of its plants just this week. But there is a lot of commitment for new nuclear across the board. We're clear, not all of these are places we're going to deploy Rolls Royce SMRs, certainly, but nonetheless, the amount of new nuclear investment worldwide is going through the roof, and there's lots of commitment. We do not see that the demand will be a problem. The problem is going to be the capacity to construct these new nuclear reactors. The supply chains do not exist. The skilled labour and workforce does not exist. Being able to meet the challenge is a significant concern, and so that is where we spend most of our sort of sleepless nights worrying about how we're going to actually deploy as many of these as we think we could. So I will leave it there, and I've got one final slide that touches on those concerns. So this is an energy scenario forecast from 2050. There are many like it. They all look broadly similar in that fossil fuel derived energy still represents around 50% of the input energy come 2050. I mean, talk about sleepless nights, that's a stat to keep you awake. And I think if we look to North America and the UK and nuclear progress and developments, well, the real measure is how this changes over the next 5 years, over the next 10 years, over the next 20 years. Because if we get to 2050 and this is what it looks like, then I think we can safely say that we've not achieved the goals that some of these organisations are set out to achieve. So at Rolls Royce SMR, our vision is clean, affordable energy for all, and you know, a stark chart like this really hammers home the need for that. So hopefully, as young communities in the industry, we can really drive some change. And you know, how satisfying will it be to prove, in this case, the DMV absolutely wrong, and that we've decarbonised far more of our society. In fact, all of it. So yeah, that's it from me.
Okay, thank you, Mike. So we're going to start to address the questions now. So I'll start with some of the ones for Mark. So just to start here, how much interest does OPG or Ontario have in building large reactors over in addition to the current SMR project? And so what would look like the time frame for these new large nuclear reactors, and how likely would it be that CANDU is actually selected for the technology for the next new build?
Sure. Yeah, so overall, OPG is definitely reviewing technologies and opportunities for larger scale deployments throughout Ontario. We're looking at our existing sites and determining which ones would be suitable or feasible for a large scale nuclear technology or plant. In terms of which technology we'd be going with, I think it'd be similar to what we did with the SMR. There'd be a technical evaluation that would take in multiple different factors, commercial timeline, and overall suitability for our grid before the decision would be made. But CANDU obviously is not off the table, but we would have to go through an evaluation before we determine which technology we would be going with. But we are currently investigating other nuclear applications, both small and large scale, for the Ontario and potentially Canadian grid.
Yeah, and I just wanted to add one point here as well is for those that aren't aware, we also have Pickering, which is looking at extending 4 of its reactors another year, and also looking at the possible refurbishment of 4 of those reactors for another 30 years. So again, lots happening within Ontario power generation with the Darlington refurbishment, SMR projects, potential new builds. So lots going on. But yeah, and Canada right now doesn't have the enrichment facilities, so that is why all of our reactors are CANDU technologies. So that would be a challenge to us as well for large reactors is we don't actually have the enrichment capabilities right now. The next question is about, has OPG considered using SMR technology not only to add electrical generation to the grid, but also using the process heat to offset industrial processes like hydrogen production?
Yeah, short answer is yes. We're looking at how we can electrify some transit grids. Hydrogen's a large candidate for that. And that's where X energy and some of the advanced technologies would come into play, offsetting diesel or some of the other technologies that they would be using to create that steam, to create high quality steam using a nuclear reaction, and decarbonizing as much of the process, if not all of it, as possible.
And you mentioned earlier on in the presentation, a large increase in nuclear would be required to reach net zero carbon emissions by 2050. Will the Darlington SMR project be enough to meet that increase? And if not, are there other plans for new SMRs, nuclear power plants, or increasing the output from the current plants?
Yeah, so short answer is no. The Darlington Unit 1 or DNNP Unit 1 won't be enough. But as mentioned earlier, we are looking at our other facilities, our other properties to see where a large or other SMR deployments would make sense. So we are looking at what we can do to meet that using other technologies.
Yeah, for those that aren't aware, OPG also operates hydro stations. We have solar installations. So it's 10,000 employees, a huge, huge company doing lots of different things. And last one for you, Mark, then I'll turn it over to Sarah for Mike's questions. What was the main driving factor for choosing BWR technology instead of the Gen 4 SMR technology?
Yeah, as mentioned, the technology selection went through a multifaceted technology evaluation. We started with I think it was up to probably more than that, but eventually down selected to 14, which down selected to 3 technologies that we went through a very rigorous and detailed technology evaluation, helping to develop their technology, sharing some of our operating experience as we went through and helped inform their tech design decisions. One of the kind of key aspects was having a unit that would be commercially available by 2028, 2029 was a big driver. So making sure that we were ready, we had a technology that would be passed through the regulatory process and be in construction was a significant factor for the overall program. But I wouldn't want to say they would be the main driver, but I would say that's probably one of the bigger ones towards why the BWR technology was selected, based on it's a miniaturization of existing, well-known, well-established technology.
And that makes a lot of sense here in Ontario as well. They saw their energy forecast, they saw the need for additional generation. So if we weren't fast enough, it was going to be gas plants, it was going to be other type of carbon emitting technologies. So we might have lost our foothold in the nuclear realm there. So it makes a lot of sense. All right, Sarah, I'll turn it over for your questions for Mike.
So Mike, the first question is, do you think the first Rolls Royce SMR order will be in the UK or from abroad? And where do you think the first unit would be first deployed? Oh, I don't know if I'm struggling to hear you.
Oh, Mike, you're on mute there, sorry.
Yeah, it's a really good question, and it's good that the two parts are split, because the first order and the first deployment, depending on where they are, can definitely overlap, and you know, the water definitely gets muddy around timescales with international deployments in different regulatory regimes. The UK has a plan and is moving towards that, so things are looking good. It's our home market. We've got experience of supply chain, things like that. We are working with potential customers in a number of locations, some of which are quite bullish, and you know, we've supported governments really looking again to deploy new nuclear. So quite who gets there first, I think there's still a long road to go before that, and I wouldn't want to call it, certainly not not today. But and then, you know, where will be the first to be built? It's certainly, we've got an edge in the UK because we have existing nuclear license sites, which really helps. You know, we know where some of these first SMRs are going to be put, and that really gets you a leg up. So I think the UK will be a safe bet there.
Great, thanks, Mike. And another first of a kind question. So who does Rolls Royce SMR envision will be the initial developer, owner, kind of operator of the Rolls Royce SMR?
Links into the previous question, I suppose. There's a number of candidates that fit in those roles, you know, across those 6 pillars and development entities looking to bring things together. It's a question of who gets there first, really, isn't it? It's you know, there's so many different options in different jurisdictions. It's really hard to call. With things like the UK government support and Great British Nuclear, you know, when things are hanging off political whim, that can turn in, you know, in an instant. We've seen what happened in Germany, and it's easy for something that you might think is in front to then end up going in the wrong direction. So yeah, it's really difficult to call at this stage. We're hoping that by the end of this year, early next year, we're starting to really launch formal projects, and at that point you've really got dates to work towards, like OPG with 2029, having that date and where that is, and you know, all the players involved. That's then really important, and you can actually then drive forward. So soon we should be able to hopefully give a better answer on that.
Great, thanks, Mike. We've got a couple of other questions. So the first is, what SMR technology is being developed in the UK, which is seen as a competitor for Rolls-Royce SMR? So if you could feed in a little bit more about that.
Yeah, so there's quite a few, and most of the technologies that are looking to deploy in the UK are not necessarily developed in the UK, if that makes sense. So the likes of GE, Hitachi. There are a number of there's about 6 organizations now that have applied for the generic design assessment. So we've completed step 1. There are 6 organizations in the queue to start. So they'd be a good, you know, good place to look for sort of main competitors. There is an additional competitor that's made statements around not wanting to go through the GDA and looking for other you know, other regulatory routes for deployment. So there's certainly a lot of competition, not quite as much competition as some parts of the world, like Poland, where I count around 9 separate designs, all claiming that they're going to deploy within this decade, which you know, is going to be challenging.
Fantastic. I think we've got a question here that kind of ranges between Mark and Mike, so maybe you could both answer this question. So it was in regards to, I don't know what this stands for, but hopefully you know what the expected LCOE is for Rolls Royce and for OPG, maybe a likely range of values. I'm going to hope that you know what that means, because I don't. I don't know.
Levelized cost of electricity or energy, depending on how you look at it. So I'll go first as the technology vendor, I suppose, and then Mark can tell us how much that aligns with his expectations. So we, as Rolls Royce SMR, are targeting a range of around 50 to 70 pounds per megawatt hour. Now, there's a huge range there because there's a huge number of variables in how you calculate that, and whether that's, you know, what are you talking about? Are you talking about the first SMR, in which case, you know, you've got a lot of risk profile on there. You're not through your learner curve in manufacture, so things are more expensive. Are you talking about your nth of a kind SMR, which is, you know, our sort of down the line when we've really productionized this as a product? How are you then deploying it in terms of your debt and equity ratios and the cost of capital? You know, is the government funding it? You know, if you look to projects like Baraka in the UAE, where the you know, the government has a lot of money with very low cost of capital, it drastically changes all of those business case assumptions and what comes out the other end as a cost of energy, which is, you know, as a consumer, what you care about.
Yeah, and I think well said. I think not knowing the current conversion rate from Canadian to British pounds, I think that's roughly around the same of what we're targeting. So, you know, again, multiple factors with first of a kind, the regulatory environment. But no, I think Mike, you hit the nail on the head.
Great. We've got a few more minutes, so I'll ask maybe one more question before we wrap up, Matt, if that's okay. So Mike, given the necessity for extensive government support to make all of this work, do you have reasonable confidence that the current and near future UK governments are capable of the strategic competence needed to support this? Tricky question, I'm sure.
Yeah, I am fully supportive of the UK government. So the UK government is behind the Rolls Royce SMR program and gave us a grant of 210 million to set up in the last stage, which has been instrumental in enabling us to accelerate out the blocks and make the progress that we've made in the last 18 months. The launch of GBN, you know, shows real commitment to the targets that they've set. So yeah, I think everything's moving in the right direction. We're making great progress with the regulatory body, the ONR, and the Environment Agency and Natural Resource Wales. Everything's looking good. We're getting all the support we need. Lots of good relationships are being built. It's just it's a long road. There's a lot of time to go. And yeah, keeping all that momentum up and critically, you know, galvanizing the supply chain with money starting to flow. That's the next step that's, you know, we really need to hit.
Yeah, so maybe I'll ask one final question for both the panelists here. Is what, based on the UK and Canada, what is your perception on people's reactions to SMRs when you mention this? Have you seen them become more positive? Are they still reluctant? Or has recent changes like Germany and some of the others been a case study in favor of nuclear? Just kind of curious. I'll start with maybe Mark and then flip it over to Mike.
Yeah, I think over my career, I've definitely noticed a shift. You know, a lot of people, when Fukushima happened, it was a bit of a moment for the kind of energy capacity that these plants have to be, you know, in the forefront in people's minds. But I think based on the advancements that we've done, demonstrations of commitment to safety, the cultures that we have as operators and technology developers and professionals in the industry, as well as the, you know, the climate change imperative that we have globally. I think looking at the amount of energy that we will need, looking at the technologies that are coming out into everyday life, like electric cars, electrifying certain grids, the government's subsidies and plans towards tax benefits for green technologies, I think overall, most people, when I say that I'm on the Small Modular Reactor project, are quite interested. They want to hear more. They want to, listen about what the technology is, what's going to be happening in the next few years, and more open to it than I think they have been, at very least in my career. So I think it's a very promising time internationally and specifically in the Ontario landscape for new nuclear.
Yeah,
And
I agree with everything Mark said, and I think the events in Germany will have long-lasting impacts. However, not necessarily for the nuclear industry. I think actually the conversations that it has created across the rest of the world, the amount of real data and data-driven conversations that have arisen because of that, has only served to solidify the view that net zero needs nuclear. And yeah, so I think I agree. Positive conversations usually everywhere. Very rare to find negatives.
Okay, well, thank you both so much for your very informative perspectives. I think there's a lot of enthusiasm. We can see by the 100 people that are on the call here that lots of questions came in. We unfortunately didn't get to answer all of them, but this will be on YouTube. We will post this, so if your friends, colleagues missed this, it will be posted. Sarah, any final comments from your perspective for NAYGN?
Just like to say a really big thank you to both our fabulous presenters. It's been great to have a collaboration and an international perspective as well. We've really, really appreciate that. So thank you.
Yep, and one final thing, I did put in the 2 links to join membership for both NAYGN and NIYGN. So if you want to hear more webinars, get more active in our networks, that is how you can do that. Again, one final thank you to our presenters. I want to thank NIYGN for collaborating with us also for the Fusion webinar last month and now SMRs. And thank you everyone for joining across multiple time zones. Yeah, have a great day.